Okay, imagine this. What if there was one single theory that could tie together the standard model, gravity, and cosmology, and do it with literally zero adjustments? A theory that doesn't just describe our universe, but actually calculates all its fundamental constants from a single foundational idea. Well, that's exactly what we're going to dive into today, the incredibly bold claims behind something called the 255-degree lock.
It all kicks off with this really specific, totally testable prediction. The theory says if you build a 10-centimeter shell and you drive it at 1 terahertz, you will actually measure a direct force coming from the vacuum of space. And here's the kicker. That force will have this super sharp, unmissable peak at a phase angle of exactly 255 degrees. Now, this isn't just some random number they pulled out of a hat. This is supposedly the universe's one true preferred state.
And this is what makes this whole idea so completely radical. It claims to operate with zero, none, no free parameters. Just for a bit of perspective, our best theory right now, the standard model of particle physics, has about 20 of these things, numbers like the mass of an electron that we just have to measure and then plug into the equations by hand. This theory says nope, don't need them. Every single constant is calculated directly from the theory's own internal logic. It's an unbelievably bold claim.
So that brings us right to the heart of it all, the 255-degree lock. Where on earth does this number come from? It seems so specific, so random. And why is it supposedly so important to everything?
This is the central question, isn't it? What is so special about 255 degrees that it could be the master setting for the entire cosmos? Well, according to the theory, the answer comes down to a really cool concept called geometric dynamical closure.
So what does that actually mean? Geometric dynamical closure basically says that the universe, as a whole system, has no choice in the matter. Its final state isn't some lucky accident or the result of cosmic fine-tuning. Instead, the fundamental geometry of the system itself forces it compels it to settle into one and only one stable configuration. Think of it like a ball rolling down a crazy, complex landscape, but there's only one single valley it can possibly end up in.
Okay, so how do we actually get to 255 degrees? It's a three-step dance. First, you model the universe's phase as just an angle on a sphere. Simple enough. Second, you apply some really fundamental symmetries, which creates an energy landscape with three equally stable points, 0, 120, and 240 degrees. But, and here's the crucial part, a dynamical correction, which just pops out naturally from the theory's own math, breaks that perfect symmetry. This correction pushes the single, true, stable minimum, the lowest energy point, over to precisely 255 degrees. It's not a tweak, it's a calculated result.
All right, so the vacuum of space is locked at 255 degrees. So what? What does that actually mean for the particles that make up you, me, and everything we see? Well, as it turns out, the consequences are absolutely profound. This is where the theory claims to derive the properties of matter itself.
Here's the big idea. Particle mass isn't something a particle just has. It's actually a calculated result of a misalignment. See, particles like electrons, they have their own natural positions on that circle at 60, 180, and 300 degrees based on the underlying symmetries. But the vacuum itself is stuck over at 255 degrees. A particle's mass is literally determined by how much of a mismatch there is between its natural spot and the vacuum spot. The bigger the mismatch, the heavier the particle. So you run the numbers, you calculate the misalignment for the electron, and what do you get? A mass of 0.511 mega-electron volts. That is a perfect, spot-on match with the value we've measured in countless experiments. And remember, this wasn't fine-tuned. It's a direct, calculated consequence of the geometry.
And this isn't a one-trick pony. The exact same principle applies to everything. You take the top quark, which is the heaviest fundamental particle we've ever found, run the same geometric calculation, and it spits out a mass of 173 gigaelectron volts. Again, a dead ringer for what we observe. Being able to calculate the masses at both the lightest and heaviest ends of the spectrum from the exact same principle, well, that's a pretty powerful claim.
And it's not just about electrons and quarks. The theory claims this same geometric machine can derive the masses of the W and Z bosons, predict the correct ordering of neutrino masses, and even calculate how they mix together. All of these fundamental properties of our universe just falling out of that same 255-degree lock.
Okay, but now for the main event. The theory takes aim at what is, without a doubt, the single biggest, most embarrassing problem in all of modern physics, the cosmological constant. The energy of empty space itself. You see, our best theories, like quantum field theory,
predict a value for the vacuum energy that is catastrophically, wildly wrong. We're talking wrong by about 120 orders of magnitude. It is, by a huge margin, the worst prediction in the entire history of physics. So how on earth does this framework even begin to solve that?
The solution it proposes is something called a triple-factor suppression. It starts with that same catastrophically huge number from standard physics, but then it applies 3 different suppression mechanisms that are already built into the theory. These aren't patches. They're natural consequences of the framework: a global constraint on total energy, a factor for the universe's preference for that 255-degree state, and a final correction for how energy changes at different scales. Together, these 3 things just ratchet the vacuum energy way, way down. And when you multiply that huge, wrong number by these 3 naturally derived suppression factors, you get a total suppression of about 10 to the minus 120. It precisely cancels out that massive, horrifying discrepancy, and it gives you a value for the cosmological constant that perfectly matches what our telescopes actually see out there in the universe.
So let's just step back for a second and think about the bigger picture here. What would it actually mean for us, for science, if the universe really worked this way?
This quote from the source material really just says it all. In this model, the state of our universe isn't some lucky roll of the cosmic dice. It's inevitable. It's a direct, unavoidable consequence of its own fundamental geometry and dynamics. That 255-degree lock, the source of all these calculated constants, is presented as something that simply had to be.
And that just leaves us with this one last, really fascinating thought to chew on. You know, we usually think of the laws of physics as these rules that we go out and discover with experiments. But what if they're more like mathematical theorems? What if the constants of nature, the speed of light, the mass of an electron, aren't just arbitrary values we have to measure, but unique, singular answers waiting to be calculated from first principles?